Hello, dear friends. I am Matilda, technical expert at Radonix. We are here with the third part of the tutorial on installing and configuring Radonix ProLin series controllers. In this part of the tutorial, we will introduce the menus and buttons on the screen, as well as explain the settings and how to configure the software in order of priority and importance of the parameters. It is important to note that due to the existence of different interfaces, there are various settings and parameters. We aim to cover all the details. Since the 3-axis interface is the most common, the tutorial will start with this interface. The training provided is not absolute and definitive, as different settings apply to different interfaces. First, we will examine the general interface of the software. In the lower left corner of the screen, you will see the Open button. By clicking on the Open button, the operator can load a G-code or DXF file. As soon as the G-code is loaded into the software, the dimensions of the workpiece are displayed at the top left of the screen or in the toolpath section. As shown, the DX, DY, DZ values and the total work length are visible. Additionally, you can hold down the right mouse button to view your design from different angles, and by holding down the left mouse button, you can move the screen to the right, left, up, or down. In the lower right corner of the software, you will find the Exit button, which is used to exit the software. It should be noted that after making any changes to the settings in the settings parameters, the operator or user must click the CT button and then confirm the settings by clicking OK. To apply the changes and achieve the desired result, you must click Exit, close the software, and then run it again. Next to the Exit button is the Min button, which stands for Minimize. Pressing this button does not close the software, but minimizes it to the taskbar. By clicking it again, the software will reappear on the screen. Settings is one of the most important sections of the software, and all changes in the machine's operation are made through the parameters associated with it, which will be thoroughly reviewed in detail. On the left side of the Settings button, you will see a cream-colored rectangular bar. After double-clicking on it, a window named Debug form will open. Through this window, you can check the performance reports of the controller and the software. Additionally, at the top line of the debug form, the version of the Radonix software is displayed. For example, Radonix Cam Pro version 1.3.86. In the second line, the type of interface is shown. Any alarm or error that causes a disruption in the machine's operation will be visible in this debug form window. Additionally, by pressing Alt plus Ctrl plus Shift plus PRTSC on the keyboard, a shortcut for generating a report on the controller's operation, you can open the debug form window. At the top of the screen, you will see the online light. If this light is on, it indicates that the connection between the controller and the computer has been established. In the second part of the tutorial, we explained how to set up the IP and establish this connection. To the right of the online light, there are the X-axis, Y-axis, and Z-axis lights, each representing an axis. If the light is on, it means that the respective axis is active. The alarm light is an element that indicates a fault or issue with the connection between the controller and the drives, or a problem with the motors or drives. If an alarm occurs, a red message appears in the rectangular section at the bottom of the screen, as previously explained, and the alarm light turns red. For example, in this case, the alarm light is on, the X-axis light is off, and you can view the controller's performance report to understand the cause of the alarm. When the report is opened, the reason for the alarm will be identified. The relevant error is related to alarm X. Emergency. A fault in the emergency inputs is indicated by this light. The emergency inputs can include emergency stop buttons and feedback from various parts of the system, defined by the device manufacturer. In the Radonix controller, multiple emergency inputs can be defined. As mentioned earlier, you can check the source of the fault from the debug form. By going to the debug form, you can see the detailed reason for the error in the program. For instance, the error is caused by input number 9, indicated by emergency I09. In the upper right corner of the screen, you will see two parameters named absolute and relative. The absolute parameter reports the coordinates relative to the home point. The relative parameter reports the coordinates relative to the reference point. In some interfaces, below the absolute parameter, there is the word velocity. This parameter indicates the speed of movement along the toolpath. Home button. By pressing this button, the machine moves to the home point. The speed of moving to the home point can be controlled in the settings, and it is recommended that this process be performed slowly. The axis continues to move until the home switch is found. After the switch is triggered and its status changes, the direction of the axis is reversed, and the movement continues until the switch returns to its original state. Below the Home button, there is a button that, when pressed, causes the axis to move quickly to the machine's 0 point without considering the homing speed. The next button is for quickly moving to the workpiece 0. Stop button. This button can be used to stop the machine's movement process. X0, Y0, Z0 buttons. Pressing any of these buttons selects that point as the reference. Below the Stop button, there are three parameters to adjust the manual movement speed of the X, Y, and Z axes. By entering the appropriate value, the desired axis will move at the required speed. For example, by setting the x-axis speed to 300 millimeters per second, pressing Enter, and holding down the Jog X button, the axis will reach a speed of 300 millimeters per second. Step parameter. This parameter determines the amount of movement for one click on any of the axes. First, the movement mode is set to incremental. When the axes are in incremental mode, entering a value in the step parameter will move the axis by the specified amount. For example, by entering the value 100 in the x-axis, pressing Enter, and then clicking Jog X plus or X minus once, the axis will move 100 millimeters. X plus, X minus, Y plus, Y minus, and Z plus, Z minus buttons. Each of these buttons moves the axis in its respective direction. When the movement mode is incremental, the percentage shown on the scroll next to Z plus or Z minus is multiplied by the value given to step. For example, the step X value is 100 millimeters. This means that when you click Jog X plus once, the axis should move 100 millimeters. But because the scroll is set to 80%, the movement amount will be multiplied by 80%, resulting in a movement of 80 millimeters. However, when the movement mode is continuous, the percentage in the scroll will affect the axis movement speed. For example, if the x-axis speed is set to 500 millimeters per second, multiplying 500 by 80% will result in a final speed of 400 millimeters per second spindle button. This button is used to turn the spindle on and off, and the scroll next to it controls the spindle speed. The scroll next to the play button controls the program execution speed. The terms tool and set tool, which you see below the spindle button, are related to the tool change operation, which will be explained in detail. In the tool section, the number of the tool to be called is entered. The set tool button is designed to adjust the tool height. With this, we have reached the end of the third part of the tutorial. We hope that this part of the training has been helpful to you.